Hello, everyone. For this episode of the Better Products Podcast, I bring you Neil Bolding from MacDermid. The conversation is centered on membrane switch technologies. We talk about various performance characteristics of the technology set, as well specifically durability, test methods, cleanability, which is a great topic, and the future evolution of membrane switch technology. So, without further ado, I bring you Neil from MacDermid. Thank you. Hey, well, welcome everyone to the latest episode of the Better Products Podcast. Really excited to have Neil Bolding from Autotype with us. I'll say McDermott, and then I'll let him do his own intro. But Neil, technical manager is your official title, but I'll just say I'll let you give the full intro because when I think back to at least when I boomeranged back to the family business in 2005 and I started attending trade shows, you were there, and I'm sure you had been attending them a little bit longer than I have. So I'll let you say the number of years you've been not only with McDermott but in the industry. But thanks for being on the podcast, and I guess I'll just ask you to introduce yourself. And again, welcome to the podcast, Neil.
Thanks, Steve. I greatly appreciate the opportunity. And yes, it is an interesting time that we certainly live in. The company goes by the name now of MacDermid Enthone Industrial Solutions. MacDermid bought the Autotype company. I think it was most probably back in 2005 when you came back along into the industry. But I have been working for the company and formerly the Autotype company since 1983, believe it or not. But in the United States since the summer of 1986. I came for a couple of years, and as they say, the rest is history. I've supported the company in many applications over the years. Most people know me certainly from a technical support role, but also done a lot of marketing, helped out in sales. I think the only role I haven't done is accounting, because clearly I can't count. If I came for two and have been here now 34 years, there's no hope for me, is there?
I think there's a lot of hope for you. Don't
Yeah.
worry about it, Neil. And I know that in this conversation, we're going to be talking all things human machine interface, specifically membrane switches. So I'm going to dive right into, into that topic. So in like this full spectrum of HMI options, human machine interface options, which I know MacDermid, of course, I've always known MacDermid for, among other things, being a supplier into this space that we not only use, but several people in our industry use. But I guess when you look at all those various human machine interfaces and all those options for a brand owner, where does, I guess, membrane switch technology fall with respect to the others in this grand space that I'll just say the human machine interface technology space?
Oh, that's in some ways a tough question, isn't it? And we most probably should look at this from a historical perspective, and use some of our time um, um, from the early days of membrane switches up to some of the latest technology today. A lot of people who are in the industry have been sort of manufacturing switches or making membrane switches for, it must be close to 40 years. Um, and the Autotype films have been around for very close to 35 years, I would say now. So we did come in at the early days of the industry and are looking to um, whichever forms of technology go in the future to support whatever those um, industries tend to be. We certainly will spend most of our time today, I think, talking about membrane switches, but other forms of switches, such as capacitive touch or resistive display type of controllers, will I think, all have a role to play in either imparting information to people and being machine controls, whether those are machines that could be within an industrial sphere, controlling machines themselves, making things, whether it's perhaps in a medical environment, in a hospital, as infusion pumps, or a switch to change the position of a bed, whether you sit up or lie down. Um, Appliances in your house, at home, whether it be in laundry or in the kitchen. What else can we think of? Switches in airplanes, the backs of seats. You still sometimes have displays, don't you, and controls to switch what you might be seeing or for lighting. And I'm sure there are a few other applications that we can all come up with, outdoor applications as well, not just within indoor environments. Switches to control oil pumps, controls down mines even. We've had our films part of switches in all these whole host of different environments.
Yeah, and we're going to go into, I can't wait, of course, we got some of the future questions. We're going to get into details of why someone would choose a membrane switch in some of those detailed environments. Prior to this call, I was looking at a couple of research studies online, and it's amazing too, for a technology as old as membrane switches, they're still forecasted to grow. I just took a peek
Oh,
at it, and it's just, it's not hockey stick, but it's just slow and steady winning the race, medical, industrial, consumers growing a little bit, but mostly you're in that industrial, medical, aerospace type environments. And it's just really an interesting technology that is tried and true. And we're going to talk why it's tried and true in a little bit. But the other comment I wanted to make as you were talking, thinking about the old membrane switch symposium and SGIA, and just how when I came back and rejoined Tapecon, how that was just an annual thing, and people have been in this industry for a long time, continuing to invest in the industry. ASTM standard committees, which I know you've played a role in, and just a lot of people that have contributed to it. So it's
well,
just
I
it's
can
it's
say on that
old new again, right? I mean,
yeah, on that note, the first ASTM committee meeting on membrane switches was January 1991. So now we're talking ago. I'll admit I wasn't at the first couple of them, but our company was. But since then, regularly you had suppliers in the industry, you had companies like yourselves who manufacture the switches. We all came together. In those days, we started off 3 times a year and then sort of branched twice a year to look at standardized test methods for um, membrane switches. How do you test? What do you test? And it wasn't so much that we wanted to develop, shall I say, standard performance requirements, but they were performance requirements from a perspective of how do you test for it, so that we all tested in the same way. And we got the brightest people within the industry, from suppliers, not just from a film perspective like ourselves, but the ink suppliers, the graphic inks, the conductive inks, the adhesives, um, the connectors, the dome supplier manufacturers, as well as a good number of companies who actually made it, as well as in those days test houses got involved. So it was all to try and make sure that we were, shall I say, singing from the same hymn book. So when we compared something or we talked about something, we were talking about the same things, and we could have a reference point to go from.
Yeah, it's nice to have the common vernacular. I mean, let's just dive right into what are some of those performance characteristics. I mean, what are people really looking for, and what makes people so confident with membrane switch technologies that the performance is there?
Well, when you think of a switch, what's it got to do? Electrically, it's got to send and maybe receive signals. So within that environment, you've got at least one of the layers that's going to flex, going to move. So ensure that all the flexing requirements are going to be there. Make sure that whatever ink or whatever it's going to come into contact on the second surface doesn't degrade, doesn't break down. Ensure that the printed circuit, the electrical circuit that's being printed, doesn't decay over time. One of the challenges in the early days, of course, is silver migration, and that will always be there. But through a lot of work and a lot of development and testing, the full understanding of what was going on became very evident, and companies could design around it and process to minimize it. So these are all very important things. So the, flexing is obviously a key part of that. And we could talk about, why did polyester, for example, become the material of choice for the overlay versus polycarbonate, which was what they were originally. So the very early membrane switches were polycarbonate films. As a processor, you know yourself, printing polyester is really quite simple. Cutting polyester is really quite simple, being relatively soft. But the two key drawbacks associated with a film like that are if there's no protective coating on it, it's easily degraded and attacked by solvent, and it doesn't have good flexibility. It will crack very easily. So where polyester came in, it was great for flexibility. And that really is, I think, where some of the durability overall comes into play. Once you've got all the right materials, all the right processing, and the right design, the polyester is going to stand up for as long as you want it to stand up. So that's great. Now, the challenge with polyester, of course, is it's not that easy to print or get inks to stick to it. So, there had to be some ink development. You have to process it with greater care and control. It's more difficult to cut because it's hard. So there was a lot of changes required within the processing companies like yourselves to get it to work. But once you knew what you had to do and you had control of your processes, things then fell into place. Even quality standards like ISO 9001, controlling your manufacturing parameters and was all very important to ensuring that polyester became routinely easy, shall I say, to process. You knew what you had to do. And then from there, with everything falling into, you've got your process under control. You've got inks that were developed specifically for polyester materials. You've got adhesives that complement it. From a design parameter what works and what doesn't work now. So these can all come into play, and it's what has allowed, I think, membrane switches to become so trusted within for their performance parameters. And ASTM really, I think, helped. That was a driver of that. And since 1991, when we first started meeting, I still like to think of myself as part of that committee. We've published over 34 different test method standards, and I think that's tremendous. And as technology changes, now you look more of, say, printed electronics as becoming more de rigueur in the industry. Well, a membrane switch is printed electronic, let's face it. And a lot of those standards, well over 20 of those standards we developed for membrane switches, can be transitioned very easily over to a bigger print electronics world. So I think that has been a big positive. And also, as technology progresses, we're not back in the wild west entirely. We can fall back upon some of the knowledge that has been developed over all these years.
Yeah, that's an interesting that's an interesting point too. I never really considered membrane switch as being, somewhat of a trailblazer. You hear all these emerging printed electronics applications, but maybe the credit isn't really due as much as it should be in terms of the role that membrane switch has played over the years to, I guess, pave the road for some of the newer innovations that are coming out. That's just an interesting point. The other thing I was thinking about, when you were talking was when I remember when I came back and boomerang back to our company, one of our membrane switch design engineers has been in the industry for a long time. You talk about these test standards. He used to have that actuation tester on his desk and just be like, just constant, sound, right? And I guess number of actuations, when I think of like tried and true, the actuations is astounding. I mean, you hear like a million plus. I mean, they're getting, and it just seems to climb and climb and climb. Can you speak a little bit about that specifically? Because when I think about just a tried and true membrane switch, just the sheer number of actuations that it can withhold over its useful life and what those expectations are astounding.
Oh, absolutely. Certainly polyester has, it is the bedrock for it. But clearly you've got different coatings, textures on the surface, which also have to be flexible and embossable without cracking and degrading. The inks on the back side, the graphic inks, are very important. And then, of course, that's typically supported by a metal dome, but not always a metal dome. There are other technologies that can be used to actuate the switch. But internally, when we are developing a coating, or whether it's for the hard coats on the surface, the different textures, or ink primers on the backside, we typically look to test for as many as up to 5 million actuations. So we're not necessarily looking to build in total overkill, but people, if a switch failed at 50,000, you're going to get complaints. So, where do you find that balance? So all the different textures that we've developed over the years, our two oldest that have been around over 30 years, of course, are the fine and the velvet, which people are very familiar with. And what's nice about that, we don't use any fillers in the hard coat, so you can selectively screen print a clear window on it to clearly see underneath an LCD or an LED for your data. And then on the backside, knowing that the graphic inks that have been developed by all the major ink companies will also be suitably flexible enough to withstand that. That's very, very important. But the inks themselves have changed over the years. Solvent screen print inks were sort of the first in the industry. Stick to polycarbonate nicely, change the formulation of ink. With the primers on the polyesters, they stick nicely to that. But the US was the leader in looking to transition from solvent-containing inks to UV curable inks. Oh, I want to say most probably back in the early 90s, mid-1990s. So that's been around a while. There were certainly some problems initially with some adhesion, resistance to adhesives, but these have all been resolved many, many, many years ago. But what does the industry do? Even yourself as a company, you look to bring in newer technologies. Digital technologies are coming into play. And it isn't strictly necessarily with perhaps a digital printing ink, but you may be digitally cutting the films, or whether that be with a knife or maybe with laser cutting. Taking all these new technologies in, the films themselves, the coatings have to be able to be complementary to or withstand a lot of what's going on. And whereas our primers have been pretty decent for many years for digital inks, it's becoming so much more widespread in our industry now. I think not just from a design perspective, where companies want different designs, which are perhaps more suitable for digital printing versus screen printing, but they're shorter run lengths. So, companies are looking for newer technologies, and we've just in the process of launching our third ink primer, brand new ink primer that's coming out before year end, that is much more complementary for digital inks, principally UV digital inks, where it's got greater flexibility, greater adhesion from them. And all the testing we've done over the past year has been very, very positive. And, so even within this market space, we're not standing still. As you said, membrane switches aren't going away. And we've even come up with earlier this year a new texture along the same chemistry lines. We've got the history of knowing where our fine and velvet chemistry is, the durability of it. We've tweaked that to be for a super matte texture now, which we call touch, where if you do need something where you've got multi-finger gesture versus just pushing with one finger, you need that sort of lower coefficient of friction for your fingers to move along. So, we're not sitting still on that side of things either.
Mm-hmm. Yeah, the evolution continues, it sounds like, from all fronts. On the durability, I just continuing on the durability, let's shift over to cleanability, because especially with what's going on in today's day and age, I mean, cleaning schedules have really ramped up with people wanting to keep surfaces clean. We know that membrane switches have been traditionally, very durable to moisture and various things like that. So, can you speak to about how the technology set really fares with a cleanability schedule or enhanced cleanability?
Absolutely, and I think you hit the nail on the head there, very much, Steve, because um, the hard-coated polyesters that are in the marketplace, they've been durable to many chemicals for not just from a cleaning perspective, but if there's something splashed on them. You've got switches that are in um, garages. You, um, you've got switches in hospitals, two totally different environments. Switches in restaurants, in the kitchen area, switches at home. They're all going to see different type of chemistries. So whether it's a water-based, a solvent-containing, like IPA, which they're saying is a good cleaner, or other forms of EPA-recognized virucides. We've having our first antimicrobial film in the market since 2004. We've had Autotex AM for the last 16 years. We know, and we've tested it to all the hospital cleaners. We've tested it to a whole variety of solvents that might be used in this arena. So to have those hard coats withstand not just the frequency of the cleaning, but the physical abrasion that might go along with whatever cloth or brush you're using is critical. And this is another thing, nice thing with the chemistry of these coatings is you can put additional functional agents within them, whether it's to help outdoor life with a UV absorber or whether an antimicrobial agent. And we've, for many years, have been partnered with Microban using their technology. And I think that that's important because to ensure that we meet their specific requirements for the efficacy of the products, to know that you've got the performance requirements against microbes is absolutely critical. Now, of course, these surfaces do need to be cleaned, and we're seeing, as you say, being cleaned more and more frequently. These surfaces are tough to that, and it's important also to know that they work so that the surface remains cleaner between cleanings. And I think that's one of the key things there. So the reputation to say, yes, we have an antimicrobial functionality and that it's going to be cleanable and durable for the life of the product is absolutely critical. And that's our reputation on the line. That's your reputation on the line. That's why companies choose our products and for our reputation and the likes of Microban's reputation.
Yeah, and abrasion resistance comes to mind too. I mean, it's one thing that it's cleanable, but you never know how hard someone's gonna put their elbow into it, right? I mean, the
Well,
abrasion resistance is probably pretty tried and true, also, right?
and to have standardized test methods of how you test for the durability, the cleanability. It's not just at the end of the day putting a wipe on something, giving it a wipe and say, yep, that looks good. But we soak the film in these cleaners for 24 hours. We take specific weights on bristle brushes over a period of time to try and standardize what cleaning we're doing. And then in the case of the antimicrobial film, sending that off for efficacy testing after it's been cleaned. Have these cleaners had any impact on reducing the performance of the product?
And so, Neil, if I'm a product engineer and I want to get is there are there's are these ASTM standards that you're referring to where I'd be able to look them up, and in my design I want to have a specific characteristic or meet a specific specification? These are all look-upable type test methods.
Yeah, certainly the solvent testing is standard, and there are a lot of a lot of OEMs in a whole variety of industries. They tweak them a little bit. That's their want. They're trying to sort of get a leg up on everyone in terms of performance characteristics. But abrasion resistance is standard. Solvent resistance is standard. And then when you think about the performance requirement of a membrane switch, what are you doing to it? Actuating it. So you mentioned about your engineer having his tester in his office. The pressure. Oh, I'm sorry about this. My buddy came to say hello. Let's, well, be good boy.
Special guest has showed up.
Yeah, this is Tango. He'll be quiet, I'm sure. Um, the actuation rubber on the head of it, the pressure that's being used, the frequency of actuation, those have all been standardized. They're very, very important at the end of the day. So to ensure that when, say, as a supplier, manufacturer supplying materials, what we say, you can, if need be, replicate, or if your customer, your OEM, chooses to test, they test in the same way and can validate what we are all saying.
Right. No, that's great. And shifting gears, I guess, talk in terms of the future. I mean, where do you see the membrane switch technology evolving? I mean, obviously, there's a lot of mega trends right now. Industry 4.0. People, of course, are looking at lightweighting a lot of things. Everyone's looking for cost reductions, but products are changing. So,
They
membranes
are.
have to change with it. So, just curious, what do you see kind of in the future? What's the future of membrane switches in the technology set?
Well, I think we could have not just a whole 30 minutes of talking about price considerations, so I'll take that off the table. But looking at the newer technologies, I see a lot of these technologies not necessarily strictly replacing membrane switch, but replacing maybe dials, knobs, controllers, more conventional type of switching. Certainly, membranes will, or some will go. Touchscreen controllers clearly are very good, but they don't work in all environments. They are far more costly, and often will have far more, shall I say, what, potential control capabilities than what a membrane does. Membranes are very simple, shall I say, very simple switch to do simple functions. Whether it be up, down, across. It's to simplify, shall I say, the controls.
Mhm.
Now, where we see some of the newer technologies like capacitive touch come into play, I don't see them necessarily taking a lot of membrane switch business. I see them taking more conventional slider controls, rotary dials in large market applications. Could be appliance, although very tight for cost control, of course, but certainly see it in automotive. But I'm not really aware of any membrane switches as we typically would know them in the cockpit of a car.
Mhm.
So I see them taking or going into new applications, alternative technologies. Certainly some capacitive touch may go into some simple controls, whether it be maybe for spas, for hot tubs, but that chemical environment is quite tough. Now, where we see in some of these newer technologies is taking the printed circuitry, the silver conductive circuitry, and embedding that within, for example, what a lot of people term in-mode electronics or other names associated with that. Yet today, the bulk of all of those capacitive touch switches still use a printed circuit that's been adhered to the backside with an adhesive. So getting that embedded into a one film or two film option for full in-mode embed electronics. A lot of people are talking about it, a lot of marketing's going on, a lot of testing's going on, and which is essential because the last thing you want is a switch like that in your car to cause you problems. Just going to put you down, buddy. Okay, sit down,
Yep.
please.
No, for sure. Yeah, no, that's a great preview, and I appreciate that. Obviously, any one of those we could spend an entire new podcast talking about, but I'd say I'd just summarize by saying, the evolution is continuing. There's plenty of things happening in R&D departments on the material side and in
Oh,
the processor side that I don't think you're going to see the concept of membrane switch go anytime soon. So
no, and it's interesting. You asked me earlier about you know how long I've been in the industry and everything. And some people might say, wow, that must be a bit boring for you. But I can honestly say, the last few years, and I can see the next few years, there's a lot of change going along. Technology is going at an ever increasing pace. Life is not dull by any means. We might be locked down and by this dreaded virus, but business is not standing still. Technology is not standing still. I'm talking to customers on a regular basis about films, newer applications for films, new requirements for films, and we have never been, shall I say, so busy or working as well, hard is that's not the word, but as focused as we can be to bring in products to market more quickly than we ever have in the past. We've always been very cautious, knowing that if we bring out a new film and it doesn't have the performance characteristics and you make switches out of it, you're going to get complaints for years to come. None of us want that. But with the technology we have today, we're making tweaks on 30-year-old technology, and it's working, and it's working very quickly and working very well. I think that gives us all a good deal of confidence that bringing out a variant of a product on technology and materials that we have great confidence in should also give confidence to the supply chain for many years to come.
wow, great. Thanks, Neil. And I appreciate all the insights. Thanks again for
Welcome, Steve.
coming on the podcast. I'd say, that's a wrap, and I really appreciate all the insights and all the sharing. I liked the special guest that
Yes,
you brought along with you. So thanks again for joining the podcast. Neil, any final parting words before we wrap up?
I greatly appreciate it, Steve. I wish everyone who's watching this hope they're enjoying all their holidays and that everyone remains safe. And we look forward to a great and changed 2021.
Okay, great. Thanks, Neil.
Thanks a lot. It's been a pleasure.
The Better Products Podcast is about educating product teams about new materials and new technologies, all in the custom material converting and printed electronic space to help them design and build better products. So in this podcast, I'm hoping to get wide-ranging conversations with various people throughout the industry and just bring a lot of good content to the table. So if you're interested in learning more about the industry, materials, processes, how to improve products if you're on a product team, or just general know-how of what the heck is going on in this industry, then subscribe to the podcast and get ready for some more really good episodes as I bring in some great guests. Thanks.